welcome again. We will be addressing a totally different type of project, application area now. We are dealing with backup power solution. So this lighthouse project is called the Fitup project. It's dealing with backup system. And we have the pleasure to have Emiliano Novo for presenting this project. Emiliano has a background as a mechanical engineer? Electrical engineer, sorry for that. And he will present the project Fitup. Is now involved in the company that is managing the project. And he will present the company too, I suppose.
Okay, thank you for the introduction. And it's very glad for me to talk about the Fitup project. Fitup project was written in 2009 and started in 2010. It is one of the projects financed by the FCHJU. It is a project that it is closing in the next 3 weeks. So there is almost the final results of the on-field testing. Okay. The consortium is basically based on 2 manufacturers. One is the Electro Power Systems, that is my company, and the other one is Future, that is a German company that is involved in backup power as our company. 2 different kind of fuel cell technologies that I show in the next slides. We obviously included R&D centers to test the equipments and to show that we stress not only on field but also in laboratories where it is possible not to wait for a real blackout, not to think about the bottle refilling. So in the laboratories it is possible to stress a lot in terms of cycles, in terms of running hours, the systems. We also have a working page about the certification. We circulated questionnaires with the final users, with the R&D centers, and obviously with the manufacturers in order to write something about how to install the fuel cell backup systems in Europe with the support of the TÜV, and to use this deliverable to show to the European politicians that it's time not to have only technical standards, but to have also rules to apply in the real sites. As end users, this is almost all telecom operators, Wind Italy, Swisscom in Switzerland, and Turkcell in Turkey, plus Polycom Nidwalden, that is a cantonal police in Switzerland. So, 2 kind of end users, one the telecom operators, the other one it is for the security network, it is called in Europe Tetra network. Technical targets brought in 2009 were the reliability, greater than 95%, more than 1,500 running hours, and more than 1,000 cycles in terms of startup of fuel cell. The other targets are the uniform certification procedures, obviously just as suggestions to technical standards and to European politicians to move further in this aspect. And I'm glad to stay here today because there are a lot of lessons learned about the fuel cell systems and fuel cell installations, not only regarding the fuel cell power systems, but also regarding the bottle installations, hydrogen bottles installations. There is a chart where you can see where we put the systems. We have 4 systems at the JRC in the Netherlands. We have other one systems in Turin at the environment park and one systems in Stuttgart at the Future facilities. And these 6 systems are the benchmark tested systems. It was forecast to have the one system in Turin and the other one in Stuttgart in Istanbul at the UNIDO ICAT, but unfortunately UNIDO ICAT was closed at the end of 2012, so we had to move the 2 systems from Turkey to another laboratories, and the environment park accepted to test the EPS system. In the other case, the systems from Future was back in Future facility and was tested directly by the University of Lucerne. We have 3 systems in Italy, and there is a particular because in Italy there is only EPS involved due to the fact that Wind asked for a system with electrolyzer, and Future in that time was not able to deploy the systems on time. But Future was able to deploy the system for Turkcell in Turkey, in the Bursa region, because Turkcell is not in the consortiums, but joined the consortium in a second time. We have 3 systems in the Grisons region in Switzerland, Swisscom installations, and we have the other 5 systems in the central of Switzerland, 2 systems for Swisscom, and the other 3 systems for Polycom applications. Some pictures of the system installed in summer and in the winter, as you can see. We have indoor and outdoor installation, only power system installation, or in this case systems with electrolyzer. So this is the Future systems with electrolyzer. This is the EPS systems with electrolyzer in Turkey at the Turkcell site. All the others that you can see here are something from Future in this case, and from EPS in the other case, and this is one of the 3 Italian electrocells that we installed at Wind site. We developed a test strategy according of the European FCH rules. We split, as I mentioned before, in benchmark and field test. We stress the system in three classes. One is to stress the short-term backup. That is what we expected in Europe. Medium and long-term is what we expected in Turkey, and the catastrophic grid failures is what we expected for the safety network, Tetra network for the Polycom application. Obviously, we tested the short-term, medium and long-term and catastrophic grid failures for all the 19 systems. In the benchmark, we tested in order to achieve the 1,000 cycles and 1,500 running hours. On site, we decided to reduce a little bit the number of running hours and cycles due to the fact that it is not so easy to move bottles, hydrogen bottles from the gas providers to the site. So Wind and Turkcell were very smart customers, because they're thinking about this logistic issue before, and they asked to deploy electrolyzer plus fuel cell. For the other cases, they touched the fire and they burned because they asked only for the fuel cell power system. But okay, this is a case that for this kind of a test, you can see the differences. Usually in Europe, you put the bottles on site, and you don't need to replace several times in 2 years testing that we made in the Fitup project. Obviously, customer and R&D centers didn't accept to use the internal power system database in order to validate the data, and they installed an industrial PC with a preprocessors and data visualizer in order to have an independent way to write the reliability table. This is the complete scheme of the installation, where obviously a grid switch, automatic grid switch, was installed. This switch, it is the switch that it is remote controlled by, for the case of the wind installation, by Environment Park in Turin, for the future installation in Stuttgart from Luasa in Lucerne. So we simulate the grid off with the help of this switch. Usually in the telecom site, there is, not usually, there is AC/DC rectifier in order to power the radio apparatus. In all the installation, there are the fuel cell power systems and the bridging unit that we use lead-acid batteries for our case. In case of Future, they use lead-acid batteries, and in one case also supercap. DC load is the radio apparatus load. In some cases, especially in Switzerland, there are DC AC or DC-DC converter in order to power other load. In one case, only in one case, that is the Bursa installation for EPS, there is a DC AC inverter to power the AC conditioning inside the shelter. As you can see, voltage meters and current meters are installed to test fuel cell voltage and current, bridging unit voltage and current, to see how fast is the fuel cell to carry on the completely the load. And all these measurements are logged in the data logger. Ambient temperature, it is integrated in the data logger, and for the Switzerland installations, also a temperature in the hydrogen storage cabinet was installed to calculate approximately the hydrogen consumption. Obviously, temperature inflate the pressure inside the bottles, and this is an empiriometric meter to understand how many liters per kilowatt hour fuel cell consumes, but accordingly the benchmark testing, it is less than 10% of differences. This is the EPS Electro fuel cell power systems that we use for all the benchmark and for all the installations in Switzerland. Basically, there is hydrogen storage in cylinders, transportable bottles, a fuel cell integrated with DC-DC converter and bridging unit inside the, in this case, the black rack. And we powered BTS in the real site and electronic load in the benchmark testing. This is the Jupiter Future product. As you can see, it is the same concept. Hydrogen from the bottles, air from the air, the ambient air, and the differences between this and this product is that EPS is using liquid-cooled stack instead of Future that is using a Ballard air brief stack. This is the ElectroSalf. This is the new version. As you can have seen, the installation in Bursa and also in Italy had the old version because we installed it in 2011. And so right now we have, it's 2 years that we have these new products, and I had not the old slide with me, sorry. In this case, we have an electrolyzer and a fuel cell at the top. We are able to store hydrogen and also oxygen. In one case, in the wind installation, we use this technology to power the fuel cell with direct hydrogen and direct oxygen. In all the other cases, we store only the hydrogen and we use the air coming from the ambient as the future installation. This is one example of the data analysis for a real site in Switzerland. This is a Swisscom installation. In my mind, this is the rooftop installation at the top of the University of Lucerne. But by the way, it's not a trouble. We installed, no, sorry, this is April 2012. It is the last installation that we made in Switzerland because it was forecast to install this installation in another Polycom site, but Polycom was not able to have the site ready for the installation, and Swisscom helped us providing a new site. So this is why this one was installed in 2012 and not in 2011. As you can see, the system was tested, and there is also a sort of a rest time for the fuel cell in order to see what's happened when the fuel cell is not working for some days. So we stress the fuel cell a lot during the day, and we wait some days without power failures. And as you can see, we performed in this site more than 500 startups, and we generate more than 300 kilowatt-hour backup. Obviously, the kilowatt-hour depending of the real load that is installed in the site. During this period, the 4G was coming, so the site power increased. More than 100 off-grid hours in Switzerland in less than 2 years is not feasible, obviously, but it is what customers and what FCAJU asked to the Fitup project, to show that the fuel cell is able to provide a reliable backup solution. And this is the table with a recap of the test results. It is last week updated. So as you can see, the 3 goals, 95% of reliability. We reach more than 95% of reliability in all the sites, with the average of more than 99%. More than 1,500 running hours, cumulated running hours, and we have almost 8,000 running hours updated last week. In this week, it is forecast to overtaking this number. And sorry, the hours is this one, less than 6,000, but it is more than 1,500. And it is more than 1,000 startups for the fuel cell. Cumulated is almost 8,000, and both the power systems reached the goal of 1,000 cycles. So now, in the case of the EPS at the JRC and the Environment Park, they are still running to reach the goal of the 1,500 running hours. But all the 3 goals are already overtaken, and this is the best way to show that the systems are able to go in the market. Lesson learned. during this project is that all the systems had few troubles, but if the system starts, no trouble during the running, or the system starts or not. The reliability depended more on the BOP instead of the fuel cell, because we don't have troubles with the fuel cells. And what it depends, especially for the air brief systems, is that the environment as temperature and humidity influence more the performance instead of the aging of the running hours or startup cycles. The worst thing was about the cylinder replacement, because even if it is easy to move the cylinders from the gas provider to the site, no one wants to change the bottles on site, because no one wants to use the wrench to disconnect empty bottles and put the new one. In terms of safety, there is no reason to think about that, but no one wants to accept this potential risk of a leakage. And we had also a lot of leakages concerning the bottle replacement. The not uniform EU regulations was a big trouble, because in Italy we spent more than 1 year talking about firefighters and so on. In Switzerland, site survey, it is mandatory. And for both manufacturers, we had to change a little bit the installation in order to follow not the fuel cell power system installation, but the welding system installation. This is why we put just one deliverable on this certification, but was written with the final user point of view and not the technical committee point of view. So we put all the standards already approved by IEC or by ISO regarding power system and regarding electrolyzer, and also regarding the transportable bottles that we used in the installations. And now we hope that this lesson learned related to the certification will help in the future all the fuel cell manufacturers that want to install units in Europe. And the last slide is just to focalize the attention of the Ilaria Rosso, that it is the Fitup coordinator, and with very pragmatic way we reach all the goals that we wrote in 2009. And please take a look of the Fitup website. Sorry that it is .tr, but due to the fact that the dissemination is in charge of the Turkish university, and before was the United ICAT, it is not possible to have .eu in Turkey, so it is .ir. About electropower system, just a couple of sentences. Electropower systems started in 2005. Started with the technology in 2005, and in 2009 we start the real business. Nowadays we have more or less more than 600 installations worldwide. We are not present in South America, but we are present in the other countries like US, like South Africa, Australia, China, India, and so on. So for us was a very pleasure to work in this project. And hopefully in the future we will have other project with also the other fuel cell manufacturer. We tried, to be honest, last month to do that, but the project was rejected. So we'll see next year if it is possible to present a new proposal, and finger crossed to have a new project, a demo project, to show that also in Europe we can deploy hundreds or thousand units as in the United States.
Thank you very much, Emiliano.
Thank you for the attention.
So thank you for the presentation, and now the paper is open for discussion.
Just
Any
back
question?
to the pictures.
Any question from the audience? Yes.
Thanks for the presentation. I can empathize with how difficult it was to go through the regulations, right, to get the bottles installed. But did you have any regulatory issues with the electrolyzer or anything else, or was it just the bottles and the plumbing?
No, the funny thing is that electrolyzer has already a lot of standards and a lot of rules, because it is mature technology, and it is used in the welding, especially for the gold welding facilities. So there is no trouble about the electrolyzer. The issues was related to have the bottles close to the fuel cell power systems, because it is an electrical appliances, and put hydrogen storage close electrical appliances that are not ATEX product ATEX certified, because it is a standard product, standard power system that you can use when you want. It was not so easy to explain to the firefighters or the inspectors that you can do following the IEC rule, the IEC standard, that in Europe it is the ATEX, ATEX 99, I don't remember slash what the other, but it's what we call the ATEX 2. It is related to the safety of the employees in the site. But it was not easy to explain this point, because usually the bottles are outdoor, as in all the 19 installations, but usually are 50 meters far from the electrical appliances that customer usually has in the facility. So the electrolyzer was not, the funny thing is that the electrolyzer was not the trouble. The trouble was related to educate the inspector that we are not using flame. So we can put in a cabinet with the chimney that if you have a gas release, in case you release the hydrogen at the top of the installation. So this is the case, and hopefully for the next installations we can present this deliverable, because it was written also with the help of the TUV. So it's not written by EPS or Futury or other fuel cell manufacturer that want to have the way easy to install the systems, but we had the certification by the TUV.
Any other question? You can see at least that in these 3 different projects, the bus project, the backup power solution, and in the first project, the NFL project, regulation is a central word in Europe. We have a lot of different regulations, and this is also quite well reflected in your project. We really need to have harmonized regulation in order to be able to implement the use of hydrogen and the use of fuel cell, even in closed compartment systems.
Yeah, just last sentence, there's no trouble about the safety for all the 19 installation in 4 years. Nothing.
What we will do also as Fuel Cells and Hydrogen Joint Undertaking is to organize trainings for firefighters, more or less like what is happening in California. We have contact with our counter partners funded by the DOE, the Department of Energy, in order to organize training session for the firefighters in order to know what is a flame of hydrogen and what are the risks, and helping or trying to help the implementation of this kind of device for the future. Okay, thank you again, Emiliano.
Thank you.